Let me show real quick how to do things like split screens and volume views using the DMT, or rather ParaView, to visualize data from the DMT. So I'm going to open a blend time analysis I did, and I'm going to look at the time evolution of a scalar field and the time evolution of a flow field and compare the time average to the instantaneous. So I'm going to be opening a lot of files here. We're going to open up fluid all along with fluid X, Y, and Z. I'm going to open up my full impeller because I'm grabbing my fluid all, my regular impellers because I'm grabbing all of these fluids. I'm going to open up my tank. Let me grab it down here. So I have a lot of files I'm going to be loading. So I'm going to do a really kind of cool visualization here. And let me go ahead and hit apply, as it were. I'm going to turn some of these off depending on which side of the screen I'm working on. So let me split the screen to get started. And again, I'll turn on the right hand side here my tank, my 3 full impellers for 3 Russian impeller systems, my fluid all, and on the left I'm not going to have my fluid all nor my 3 full impellers showing, and in fact I'm going to only have the Z plane of fluid showing on this side. So my 3 impellers, my tank, those are all on, and my Z plane. Let me go ahead and make this tank somewhat clear so I can see what's going on inside. Have the tank selected for on this blue line around this suggests that I'm working on this pane. So make it 0.1 and I'll make that a 2D view. Sorry, a moment here. Okay, and on this side over here I'm going to do the entire fluid volume. So I'll make the tank somewhat transparent again. I'm doing it twice because now I'm operating on this side over here. I'll again work in the 2D view. And so let me zoom in here, and I'm going to calibrate everything by jumping to the last time step. And on this right hand side I'm going to visualize the scalar field. So I'll click on fluid all. I'm going to do a volume, and I'm going to look at the S1, which is my scalar concentration. Now this color bar doesn't make much sense given the fact that it's homogenized. I can change that color bar to a different range, obviously. Maybe and I can change the way it looks. What I like to do is have things go from almost like a black to a light blue, or whatever, just from a dark to a light. So I might choose something like a, here's a black, blue, white, and the white is initially high. So that's easy to flip though. I just go to edit, and this invert black, white, now the black is the high. And so if I go over to this and change the color scale to something more reasonable, maybe 0.1, I see white represents a homogenized case. And if I go to an earlier time series, I see that my higher concentration is now dark. Okay, does that make sense? So I'm going from dark to white. And again, I did that by choosing a color scale and then inverting it in the edit, right? Inverting it right there. So now I have concentration, and it gets more light as the system homogenizes. We will jump here to 400. And again, we'll let this load up. But you can see that that's a bit more organic, as it were. If you want to change the background, that's easy. I scroll on a bit down further, and I have background color. I can do all sorts of things with the background. I can have an image, maybe my logo. I can just make it white. I like the white background. But note, when I do it, I've then got to edit the color bar text to be black. So I go over here to this little E, edit color legend properties. I hit on E, and I can change the colors of that color bar here to just black. And I might just call this, concentration or whatnot. And so the point is this, is that if I have a white background, and let me go ahead and turn off the compass since that may just be distracting. If I have a white background, I got to change the text accordingly to match. Same thing over here. Maybe I'll make this white background to be consistent. So I've clicked on this side over here. So I have this blue box surrounding this split plane. And let me change the background to a white. And again, edit this color scale label to be black. Now again, I can't edit it for a closed or non-shown object. I'm looking at the fluid Z, so I click on the fluid Z, and I'll edit it now, right? I have to be on the right object I'm viewing if I want to edit and maybe just for simplicity, if you're presenting this to a client, maybe it's called speed or whatnot. And obviously this reference frame makes no sense since it's going from 0 to machine epsilon, so I can calibrate that to whatever I want it to be. Maybe I'll go to like 1.5 or whatnot. And now even within, and let me turn off the origin here. Now even within an individual frame, I can look at 2 things on either side using a clip. So I have fluid Z selected, because that's what I'm working with on my left-hand side. The blue box is around this pane I'm working in, and I can do something called a clip here. So I can clip, and I can choose the orientation of the clip, and the default it selected was good for me. This orientation is in the Z direction, which is going to cut this plane is in the X direction. It's the X plane, 1, 0, 0. So it's going to cut this Z plane into 2. And so if I turn on the clip, I can see that the clip was only visualizing 1/2 of the system, okay? So on one side, maybe fluid Z, I can choose to visualize mean velocity. And on the other side, and maybe I don't even want the color bar on that scale. Again, I can have it, I can edit it any way I want to. But on the other side, then I'm visualizing my instantaneous velocity. If I look up here, I'm looking at instantaneous velocity. So if I play this now, kind of watch this evolve, and this is kind of going to lurch forward because I'm loading this data off an external hard drive, but I'm going to get the instantaneous data on the right and the time average data on the left. In fact, let me just manually jump to some later time series so we can see this in effect. Let me go to 100 for starters. And this is before I injected the scalar, of course. But you can see I'm looking at two things at once. I can edit this as needed to change the scale. Maybe I want red, green, blue on the fluid, and then the clip. I can make it the same. I can do whatever I want to do. But there's a lot of generality here. It might make sense if I have two different color scales now to turn the color bar on this guy and edit it if I wanted to. Again, these would have to be black since I have a white background now. But to that point, you have a lot of flexibility. So this might actually make sense because look at this. The mean flow field does have a different range and minimum maximum than does the time varying. So again, you can do what you need to do. But there's a lot of flexibility here, both in terms of splitting screens, as I've done here, and splitting within a screen. So I'm going to go back to surface here so it's a bit cleaner and interpolated. I'll have this one be the surface as well. And that's a nice piece of data. And so that's how we split screens and look at lots of different results within a single animation. And something like this communicates a lot of information to a user in terms of understanding the transport physics, the time varying physics, the mean flow, the time varying flow field, I should say, the mean flow. There's a lot of information that one movie can give. And just because it's really annoying me, I'm going to change this color scale to be consistent with the right-hand side. It just kind of makes no sense to have it be different. And I'd probably want to change this color range to be consistent across the two, or else it's just confusing. So let me go over here and make it 2.0. And I'd make this one the same, obviously. Click on the clip, since I'm going to operate on the right-hand side there, and change this to, again, the 2.0, just to make it apples to apples. And if I did that, I'd probably go ahead and turn off the second color bar. But the point is this, is you can adjust it any way you need to, but you can communicate a lot from one simulation with the mean, the instantaneous, and the time varying, the effect on the time varying concentration. So, okay, if there's any questions, let me know. But hopefully that seems reasonably clear. Thanks for your time and attention.